Okay, so in our last video for Module 8, we're going to talk about geoengineering. So what is geoengineering? Really, there's two main categories that we're going to consider. One is CO2 removal, so that's taking carbon dioxide either out of the atmosphere or out of energy streams right before it goes into the atmosphere. So either at the point source where CO2 is generated or from the diffuse atmosphere. And then the second is solar reduction. So that's actually reducing incoming solar radiation. And so really where geoengineering in this sort of circle diagram of different ways you can address climate change, geoengineering tries to break the link between CO2 emissions and CO2 going into the atmosphere, that's CO2 removal, or the impact of CO2 in the atmosphere causing climate change. So solar geoengineering is trying to reduce the energy forcing. You can also tackle this problem from other aspects too, right? You can increase efficiency that would decrease how much energy we're consuming. Or you can conserve and not produce as many goods. And so that can still, we can have improved well-being while not consuming as many goods and services. And so throughout all this, we need to think about two questions. Well, one, can we do this? And two, should we do this? And those answers are, it's becoming increasingly clear, I think, that we can do this, or at least we will be able to in the future. I don't think it's quite clear yet whether we should do this. Okay, so CO2 removal. There's a whole range of options here. And this figure from Caldera et al., 2013, seeks to try and coalesce all those options into one nice little diagram. And so what you need to think about with any of these options is how long is carbon removed from the atmosphere, how much does it cost, and are there secondary environmental considerations? Excuse me. So you may have heard of, say, ocean fertilization, so dumping nutrients into the ocean to try and spur biological production, leading to removal of carbon from the surface ocean and draw down carbon from the atmosphere into the ocean. You can enhance that in different ways. You can increase the alkalinity of the ocean, and that can take out more carbon. Can accelerate chemical weathering of rocks. These all, I'd say, there's a range of feasibility here. Ocean fertilization has so far not been shown to work very well and has very unknown ecosystem effects. Probably the most likely and the things that are furthest along is direct capture from energy production. So at the source, when you're burning fossil fuels, trying to capture the CO2 and pumping it into underground reservoirs. And then there's also afforestation and trying to increase biomass in the earth. Pros of CO2 removal. So if you actually are taking CO2 out of the atmosphere or out of the point sources, you are addressing the problem of increased greenhouse gases. So this does avert future warming, and it avoids acidification, unless you're putting the CO2 into the upper ocean, then you're actually probably making acidification worse. But the cons are that it's slow for this to have an impact. So it's very good in terms of avoiding future warming, and that's very important. But if we're trying to say in the future, as temperatures warm, or even now, and we're starting to see real impacts from global warming, this isn't going to result in immediate reductions in temperature. It will take a while before this has a real strong impact on current warming. And also the reservoir has to be stable. So if you're pumping it into a geological reservoir and it's well mapped and carbon dioxide is not going to escape, then that's good. That's stable. It should stay there for on the timescales we care about, hundreds of thousands of years. If, on the other hand, you're putting it into the ocean and you have it's not getting deep enough, then mixing is going to turn that into contact with the atmosphere, and that's not really going to do a whole lot. So there's a range of options there. It does seem like we'll see some form of CO2 removal from power plants, most likely. Direct air CO2 capture is certainly intriguing, but so far there's very as a function of mass or volume, there's really not that much CO2 in the atmosphere, and so it's tough to see how we could do enough direct air CO2 capture to make a huge difference. And the ocean fertilization schemes that I've seen have not been very convincing. Now, soil reduction is say you're not going to deal with the CO2, but you're instead going to try and reduce the amount of light energy coming into the ocean or into the Earth's atmosphere in order to reduce warming. So a good way to think about this is that if we double CO2, we're effectively increasing the amount of solar warming by about 1.7%. So that means, right now, incoming solar radiation is about 240 watts per meter squared. It's increasing it by about 4 watts per meter squared. So if we want to eliminate that impact, we have to block 1.7% of the incoming sunlight. So you can do this at a whole different scope of levels. You can either put some satellites into space, either in direct Earth orbit or at a Lagrange point further out in space, to try and reduce solar costs, reduce emissions there. Now that can be very expensive. I don't think we're to the point where we could do that conceivably yet, but at some point in the future, it's totally possible. We have plenty of private individuals putting satellites in space now. Can put aerosols into the stratosphere. This is one of the topics that I think has, it seems feasible. We've essentially done this through aerosol emissions in the past, and that's been reductions in aerosols actually seems to have led to an increase in warming. So that's, it's good for our overall health, but it's also had other climate impacts. So that's I think more feasible, but it has pretty uncertain impacts in terms of how it would impact weather patterns and precipitation. There would likely be secondary effects that we would have to worry about. There are proposals to try and brighten marine clouds by increasing cloud condensation nuclei. That I think cloud dynamics are uncertain enough that those are very much, those are proposed ideas, but it's not known if that's feasible. Some people have suggested we could increase the reflectance of the ocean surface by putting lots of bubbles into the ocean. I study air-sea gas exchange, and it's intriguing, but I'm skeptical that would work. Now, increasing the actual reflectiveness of land, so like whitening rooftops is something that you certainly can do, and I think does help local heating, but there's just not that much building surface area to make a huge impact. Or you could grow more reflective plants or increase crop area. These are all things that, as I said, in thinking about emissions reductions, it's possible that we could implement some number of these, and they would help the overall situation. That said, I think both with solar reduction and CO2 reduction, there can be other issues that we might not consider, and we don't want to make the problem worse by hastily implementing a geoengineering scheme. So just thinking about the overall pros and cons of solar reduction. Pro is that it operates very quickly. One con is that, or a few cons, it doesn't stop other issues associated with CO2 emissions. So you're not reducing the CO2, so you still have acidification going on. So you still have huge impacts there. This could encourage people to delay dealing with emissions because the sort of immediate pain of dealing with them wouldn't be felt. But I think one of the biggest issues with solar reduction, especially if you're thinking about like satellites, is that if the solar reduction stops, modeling and results really indicate that warming would come back very quickly. And you would get much of the warming that you averted over a very short period of time. So you could have really more significant impacts if something like that stopped. So I think we need to be very cognizant of that when thinking about solar reduction. That said, it's important to think about geoengineering because prices for all these things are coming down, and at some point, we're reaching the point where individual governments or maybe even rich individuals could start pursuing some of these. And so thinking about the ones that do have significant unknowns and costs associated with them is important. So I don't think we're going to be saved from global warming by geoengineering, but it's important to think about, and maybe there will be some portion of global warming that can be helped, certainly by CO2 reduction or removal, maybe by solar reduction as well.